Yeah.
Yeah.
And can I make a thing for Royal Holloway? Because that's in an odd way, that's my old college. Although I never went there. I went to Bedford College, which merged with it. So here it for Royal Holloway.
You should be able to share now, Nicholas.
Yeah. Mm-hmm.
Yeah,
Right.
there we go. Can you see that photo?
Just coming up now, yep.
Yep, great. That's me. I'll shut up.
Right. So, Nicholas Booth has been a writer for over 30 years. He was the youngest Briton to ever work for NASA and read physics at London University before working on Astronomy Now magazine. He then worked for the world's oldest newspapers as a science writer for The Observer, and then as a technology editor on The Times. He has written a dozen books, including an encyclopedia on space, a look at the next century in space, as well as a book on the planets and one on the ozone layer. He has broadcast regularly, presented on radio, and worked as an editorial director, and then as a mobile publisher. With an interest in history and unusual characters, his book Zigzag, about the double agent Eddie Chapman, is being made into a film by Tom Hanks. His book about a famous forgery in Victorian London, The Thieves of Threadneedle Street, has been critically acclaimed. In 2021, his first thriller, Messiah, is being published, following on from his most recent book, The Search for Life on Mars, co-written with Elizabeth Howe. He tweets as at Thieves Book. Let's give Nicholas our usual Kaz warm welcome.
Thank you. It's an absolute delight to talk to you because I said to Alice Amanda before, I spent most of the summers between the age of 8 and 16 just down the road from you in Sanka and Durasdia. I was a teenage astronomy nut like everybody else, but I've gone off and done other things. But Mars, I always said, was my first love, and I've managed to get back to it. I thought I'd start with this photo that Stuart Atkinson, who some of you know from the Popular Astronomy Society, he made an offering to the god of war last year. It didn't really work with all the stuff that went on in 2020. What I wanted to do is, before anything else, I'm not a scientist. I am a superannuated, burnt out old hack who kept all his notes. So everything I'm telling you is from a slightly different perspective than some of the lecturers that you will have had. But unless you've been living on another planet, you would have not known about the landing of Perseverance, which I think, you know, has been absolutely spectacular. This image that's been modified by Don Davis, the famous artist, I think will be an iconic image for many, many years to come. It's going to be the last sky crane drop, that amazing system, because all the planned missions coming haven't got that. I think it'll be a lot easier on people's nerves. The parachute was absolutely amazing. That sequence, I think, also iconic. Did you know that most of the parachute system was built in Tiverton in Devon? What they also did in the typical NASA JPL fashion, they put in a sort of code which says "Dare Mighty Things," and it really is that, because this now starts the firing gun for the return of samples. You know, we just saw about the Japanese mission, but this will be sometime in about 10 years' time, samples of Mars, which I think will be an amazing achievement. This came down a couple of days ago. Oddly enough, it's Stuart Atkinson has done the image analysis. You can see, like a typical tourist, Perseverance that's made lots of nice tire tracks on Mars, and it's working absolutely perfectly. Last week at the LPSC, which is normally held in Houston, all the scientific papers or information came down. Everything's working tickety-boo, which is really, really great. The reason that they've landed in Jezero crater, and you'll be seeing a lot more of this image tonight and over the next few years, is very simply, it's a sort of geological paradise. You've got everything that you might want to look for ancient signs of life. So Perseverance has come down somewhere here between those two craters. This is slightly in the infrared, and the green stuff there, technical term, is carbonate. And what's happened is water's pierced the punctured the wall of the crater that you can see there. There's sediments that have spilled across, and it gives you everything that you might need. Now they're talking about hoping to go through towards to get some of this blocky material, which will be some of the oldest material ever seen on Mars, or certainly examined by a spacecraft. Slightly more technical for those of you geology fans, the marginal carbonates, as they call it, very unusual. On the surface of Mars, you don't normally see many carbonates because everything's covered in dust. But here is a region that's carbonate rich. You've then got the delta, where obviously sediments have been lain down and the delta remains. And remember that little knobbly bit there, the technical term again, which I'll come to. Perseverance has landed just there where that dot is. I don't know if you can see it. And they were talking about, this was a press conference about 2 weeks ago, they can either go north or they can go south. But the plan is to drive through all the various sediments to get as much information from various stages of Martian geological history. The problem is in that bit in the middle there is full of dunes. And they've learned the hard way with Spirit that got stuck in the dune region and other rovers that the rovers don't like sand. So at the moment, it looks as though they're going to head north and go that way round. And again, later on, we'll see more of those images. A quick reminder about the surface of Mars. Those of you who look at Mars through a telescope will recognize that feature there, Syrtis Major. It's one of the few things that you can see from Earth. And here are the 9 landing sites, the 10 landing sites, I keep forgetting to add Perseverance, of where missions have landed on Mars. The most north was Phoenix at 67 degrees north. That's the kind of equivalent of Reykjavik. Most missions land close to the equator. As you can see in that, most of the southern hemisphere is older. In other words, it's been bombarded and nothing much has happened, whereas in the northern hemisphere, it's been covered with lava. We'll come back to that. So we've got quite an interesting range of places that missions have landed, and Perseverance now is here on the edge of Syrtis Major in Isidis Basin. And it's a really interesting area because you've got the best of all worlds. You've got what was obviously an older crater that was gouged out in ancient times of geological time. And then subsequent to that, lava has filled it in. And nearby, there's the fossae like Nile fossae where the surface is cracked open. So it's a grab bag because this is where all the next missions will be, or American missions will be going to return samples from there. The biggest problem that they've had to date with Mars rovers of this size, Perseverance is about 10% heavier than Curiosity, is wheel wear problems. And you can see here the pattern on Curiosity, they've had wheel damage. And about a month ago, that was the latest image. That shows you, a few more holes the size of that, and then there's going to be serious problems. With any mission on Mars, because the planet is freezing, the average temperature is minus 60 degrees, there's always going to be mechanical problems that will come when they're least expected. So they've redesigned the tread pattern. And this guy, Rich Reber, we have a long involved interview with him, very, very funny interview. And that's all I'm going to do to plug the book. They've redesigned everything to take into account what he called the pointy stuff, some of those tiny little rocks that have caused damage. Again, this came down last week. There are the wheels. They're already ever so slightly dusty. They're working perfectly well. And you'll see that box there, which I'll come to because that has literally dropped off in the last couple of days. As I said, I'm sorry. That is a photograph from yesterday that was beamed down because inside that box is the helicopter. Again, we'll be hearing more of that. There's going to be a press conference this week to say when this is going to take off. So they've now got a helicopter that will be flying within the next few weeks. It's an amazing achievement and it promises another view of looking at Mars. Some differences between Mars 2020, as it was called, Perseverance now, Curiosity, they're very similar. Different wheels. It's got this sample caching system. It's got this turret with it where all the exciting new stuff is coming. But the main thing that it doesn't have is the big square box that was an interrelated set of spectrometers and tunable lasers, which is called SAM, the Sample Analysis of Mars. And that took up a third of the volume of Curiosity. And what that means is Perseverance has a different way of looking at the surface of Mars. With Curiosity, samples were dropped in there, inlets were open and gas came in. With Perseverance, it's going to go up close and personal on the end of that instrument arm. The most interesting discovery in recent years is about a very, very illusory thing on Mars. This was the summer of 2019. It came from an email to the science teams, and it ended up on the front page of the New York Times. The puff of gas, which got people very, very excited. The puff of gas is methane. Now, my school asked me not to do A-level chemistry because they didn't want the average grades lowering, so it's a bit ironic that I'm going to talk chemistry. There is a representation of methane, 1 carbon, 4 hydrogens, and there are different forms of it. Carbon-13, depending on the number of neutrons at their center, and carbon-12. If you can measure that fractionation, the number of C13 to C12, that will give you an indication if the methane seen on Mars is biological in origin. It doesn't look like it is, and that measurement, the isotopic fractionation, is really, really difficult to make. Curiosity hasn't been able to do that. There may be other missions coming down the line that will. But the idea of methane on Mars is quite curious. The same team that Rose talking about at NASA Goddard, they've measured, because what they do is they open the inlet, they let the air in, they take all the carbon dioxide out, and whatever's left, and we're talking trace amounts, we're talking parts per billion, and this was what Curiosity discovered. There seems to be some sort of cycle. Now, to add mystery to it, there's also oxygen, atomic oxygen. It's about 1% of the atmosphere. As most of you probably know, the atmosphere of Mars is 95% carbon dioxide. There's atomic oxygen. It's nothing to do with life. It's not a biological form of oxygen. And there's the same sort of pattern. So is this because there's some sort of geological process underneath the surface that's releasing this stuff? And this is why when it's slightly warmer in the summer, at the moment, nobody really knows. But it's one to watch out for. And the problem with Martian methane is, it's a great mystery. In 2016, the European-Russian trace gas orbiter arrived in orbit around Mars, and as this shows, its aim is to look for trace gases, and to do that, it uses the sun essentially as a heat lamp twice in an orbit. You know, the sun rises, the sun sets, and its mission was to look for the Martian methane. But guess what? It's not found them. Now, because there was a global dust storm in 2018, that may have something to do with it. But the most recent spectral analysis that I've seen is this, and it shows something which happens with astronomers on Earth, where you're looking at a distant object, and using my hands is a distant object. Its spectral lines in its atmosphere, but from the Earth, you've got bigger, thicker spectral lines hiding ones underneath. It's kind of like an interplanetary peekaboo. And that seems to be what's happening on Mars, as observed by one of the spectrometers, an infrared spectrometer aboard the Trace Gas Orbiter. It seems to be that where no methane has been found, they've discovered new carbon dioxide lines, there's water vapor, and there's ozone. And it may well be that these new lines are actually sort of drowning out the signal if there's any Martian methane there. But watch this space, because that's something that's going to continue. In fact, there's a sizable body of opinion, because for the book we talked to lots of people about it, and there's still a notion that all the observations of methane to date are in some way illusory, because you're talking about such very tiny amounts. There are lots of things. It could be contamination in the spectrometers, it could be contamination in the chambers where they pumped out the CO2, but it's still a mystery that has a very curious historical resonance. In 1969, Mariner 7, which was the second, or rather third, Mariner 6 and Mariner 7 were the second and third successful missions to get to Mars. There was a problem. About a day before it flew past Mars, it went crackers, it went out of control, and the theory is it was probably a battery that exploded. So purely as a gag, one of the JPL managers said, aha, it's because of the Great Galactic Ghoul, and this was presented to him. And what I love about that is it's Mariner 7 with a chunk out of the solar panel. Only 40% of missions are successful when they get to Mars. It doesn't like to reveal its secrets very easily. But Mariner 7 in 1969 produced a very curious result, and it's here, and I'll have to lean forward because my eyesight is from a scientific paper. The moral of the story is that spectral detection of methane on Mars can trick even experienced researchers and requires extreme care in considering spectral contaminants. That's how a scientific paper would put it, but what actually happened in real life was this. There's the best Mariner 7 image of Mars. You can see there that there's a hint that there was a volcano there, the Olympus Mons volcano. Mariner 7 flew kind of over the hinterland of this region here between the South Pole. And the first results the next day were presented. Mariner 7 finds clue to life because George Pimentel, who we'll see in a second, did an overnight analysis of the spectral measurements and said, we can't refrain from speculation that they might be of biological origin. He was talking about measurements of methane. People oohed and ahed in the room. I know reporters who were in there. Problem is, it was a sort of excitement too soon, really. The infrared spectrometer, they did a more detailed analysis and that kind of went away. They realized they hadn't discovered methane. What's interesting to me is, here's the instrument built by Pimentel and his colleague George Herr from Berkeley, the University of California in Berkeley. And even as we speak, its grandson is now in orbit around Mars. Built by a consortium of different American universities, although Berkeley's involved, this is the latest infrared spectrometer now in orbit around Mars. The HOPE mission is quite remarkable in the fact that 5 years ago it didn't exist. The excuse me, the United Arab Emirates going into space in a big way. To do that, they've demonstrated that they can pull a mission off, which they've done. It went into orbit on February the 9th. This was one of the first images from a camera, and you can see there the 3 giant volcanoes. So it's working reasonably well. The mission arrived. It's in this long, elongated orbit that it's in now. And tomorrow morning, at about 2 a.m. British time, I think, it fires its engines again for another 20 minutes to get into its scientific orbit. And then really the fun and games can start in terms of scientific research. What it's aiming to do is to literally fly into an orbit where it can follow features. It's not geosynchronous, but it will be able to follow stuff on the surface. So there's the infrared spectrometer that will look at dust and water vapor, the camera, and the ultraviolet spectrometer will look at all the sort of chemical sex and violence higher up in the atmosphere. It's a remarkable achievement. Now, when I started getting interested in Mars as a kid, it was always said, well, it's a much simpler version of the Earth's atmosphere. There's no oceans. Not like that at all. It's like a series of onions where each layer that you're trying to do is to understand, you unearth another different layer. And they're finding every time now that with the different levels of the atmosphere from the surface, mid-altitude, right to the outer extremities, it doesn't quite all match up scientifically. What's going to come will be really interesting because this was again just released last week. There's Olympus Mons, the biggest volcano in the solar system. And here you can already see that the atmosphere of Mars this month is really quite dusty. And that's one of the problems. The dust in the atmosphere sort of complicates everything in a really fundamental way that isn't really understood properly. So this is why it should be simpler, because it's exactly the same physics. Mars rotates, hot air rises, it heads towards the poles. In the case of Mars, the carbon dioxide in the atmosphere freezes out, something like 20% does on the pole. You've got the different tides, but you've got dust storms. And trying to work out the relative contributions from each is not easy. Again, one of the problems is Mars is, relatively speaking, a very small object. It has a low albedo. There's not much contrast in the features. There's our friend Syrtis Major again. The first orbiter 50 years ago, Mariner 9, arrived and couldn't see anything because the whole of the planet was covered in dust. And eventually the dust dropped. And there are the 3 Tharsis volcanoes, which sits like a bulge because of volcanic activity. And even today, understanding how you go from that Mars to that Mars, the dusty one, isn't really understood. There's different theories, they've got different tests, they put the numbers into computer models, but it's inherently chaotic and small changes can have different effects. Sometimes there aren't global dust storms. So that's really going to be the focus for this mission in the next few years. The simple thing is that over the southern hemisphere, the planet is nearest towards the sun, so it's warmer, and we're talking relative terms here, and the dust gets kicked up. But again, nobody knows quite how, because to date, all of the instruments on the surface measuring wind have had problems. But now finally they're getting high quality data. So yes, it's known that the dust is kicking up, but how does that then feed into other localized dust storms? Because sometimes it does and sometimes it doesn't. And again, I'm not a scientist, but here is some, again, you go to conferences and people are talking. We discussed this with somebody for the book, and they said the problem is the lower atmosphere, the middle atmosphere is slightly friskier than we thought. We've got all these different phenomena, and trying to work out what is the relative contribution from each isn't as easy as they think. And that's really where these instruments will come in. The infrared spectrometer will look at the kind of heat flows and the dust flows, because where the heat flows, the dust follows. The ultraviolet will tell you about the top of the atmosphere, and there'll be a high resolution imager, which will be taking a synoptic weather view every day. Again, in simple terms, it's a complicated jigsaw, and some of the pieces are missing, some of the bits don't quite fit. But over the next few years, this mission and also the MAVEN mission, which has been there since 2014, built by the University of Colorado. It's an acronym for Mars Atmosphere Volatile Evolution. And it's going to be working sort of in tandem with HOPE, because what HOPE sees from a far distance, that the MAVEN mission can see closer in. One of the most interesting things that MAVEN's found is that the planet has aurora. It's in the ultraviolet. Its ultraviolet instrument has discovered those. And also, it's trying to understand the interaction between the sun and Mars itself. Mars is smaller than the Earth, 40% the size. It's got a smaller core that seems to have frozen out around 4 billion years ago. There's some leeway within that. The sun sends off this cocktail of particles. When it slows down from supersonic to subsonic, you get the bow shock. And right in the middle, MAVEN has been following and looking at what they call the ionospheric reservoir. What that means is the energetic particles from the sun rip off electrons and the atmosphere is lost to space. But how long it's been going on, the relative contribution to each, again, although there's lots of data, nobody really can be quite sure. But it's pretty obvious that Mars was a very, very different planet 4 billion years ago. Here's something that MAVEN has discovered, the ultraviolet instrument. So this was 2 days in September. A solar storm slams on the Earth. You would see lots of aurora as the particles channeled around the poles. On the surface of Mars, they go straight down to the surface. Not good at all for the possibility of life, and certainly not for astronauts who, in a few years' time might be traipsing around the surface. The key with what they're trying to do is to understand the past of Mars, to understand how much atmosphere has been pulled off, and to also have a look and to see how the interaction of the magnetic field works. And for that, you've got all this stuff coming off the sun. And
Jim, you've just entered. Can you mute yourself, please?
So it gives me a chance to, there we go. Yeah, thank God Line of Duty isn't on, that's all I can say.
I've muted him.
Yeah, thank you. So here is a schematic of the Martian magnetic field as now understood. The core isn't very active at all anymore. The magnetic field is a remnant, and as the stuff comes off the sun, it sort of twists. And one thing that MAVEN's found is this twisting magnetic field lines around the back of the planet that pushes stuff off and pushes stuff back. It's still early days, but here's an interesting graphic to show you what they've actually found. Here is Mars as a geological map. You can see the northern hemisphere there, which is smooth because of the volcanic activity. But this from the global surveyor that was in orbit in the late 90s shows you something that jumps out. Any magnetic field on Mars, the remnant field, is mainly in the southern hemisphere, the older surface. So what that means is the field was imprinted early in the planet's history, and then the core died off. And again, that is really interesting for going back in time to 4 billion years ago, when Mars would have been a very different planet. As some of you know, the InSight lander has been on the surface of Mars. It's been there now nearly 2 years, so just over 2 years. What it will be doing, it's got the first magnetometer that's been taken down to the surface, and the Holy Grail is watching as magnetic storms come in, how material then goes locally to the magnetic field there, how it goes under the surface. And already they've found something quite curious, which is this, that there seems to be the measurement at the surface of the local magnetic field is about 100 times greater than observed from space. And what that seems to indicate is there are individual rocks surrounding the lander that have got the imprints of this ancient magnetic field that are artificially bumping up the measurements. It's still early days. The problem with InSight is that everything that they thought would work and all the things that they thought would have worked anywhere else on Mars haven't quite worked here. Most famously, it has its seismometer. It's been making measurements, and there is the cable that gives the connection to the lander, which will return the data. With that, you must remember remember this image and this cable, because it's causing a few problems at the moment. It's discovered about 450 Mars quakes. The problem is Mars is windy. The lander shakes all the different bits, sensitive instruments. It can measure the motion of individual atoms at certain levels. And the problem is it's drowned out by all this noise. And since last year, so for most of 2020 and into this year, Mars is much windier, it's dustier, and they've not been getting as much data as they want because it's lost in the noise of all this. Having said that, they've located where some of these seismic waves have come from. So it's geological activity of a form. There's InSight, landed on the Elysium Planitia. There's volcanoes there, and nearby are these foci in the surface. They've measured where the waves have come from, the wave trains, all the complicated stuff, and they worked out that it's come from there. Here is a view of Cerberus foci. They're basically cracks in the crust. Mars never differentiated out to plate tectonics. The surface cracked a little bit, and that's what you see. And here is a high resolution image of Cerberus foci. You can see there what looks like there've been landslides. And one of the theories was, well, maybe we've measured a landslide, but they've already said, no, the kind of wave patterns are very different. And the current theory is what they've measured is somewhere under the surface, there's lava that's still relatively speaking warm, and there's sort of cracks and it's moving, and that's what they've measured. But it's showing that Mars is slightly more active than the moon, but not as active as the Earth, but there's the remnants of geological activity. The biggest problem InSight's had is this. There's a standard JPL Mars lander. It's got the solar panels that open out like that. Mars has been very, very dusty, and a lot of dust has accumulated on the solar panels. Now, everywhere else on Mars, dust devils have whizzed past and taken the dust off the solar panels. Not here. Hasn't. For some reason, it's at the mercy of how much dust. And this is a simulation, so that's how much sunlight there should be. As you load the atmosphere, that's what you're getting to. And what's happened is in recent weeks, InSight is down to half power. They've had to switch instruments off just to keep the spacecraft working. Hopefully into the new year on Mars next year, things will improve because InSight is a statistical mission. The more measurements it makes, the greater its observations. This is an image from Mike Lewis in St. Albans. I just downloaded this the other day. Mars has gone from being the bright object in the sky, it's very small, but even there you can see that it's very dusty. It's very dusty, and that means surface winds, and that's really affecting the mission. There are the dust devils that others have seen, not come nearby. It had two major instruments. One of is the seismometer, which looks like the wok. The other was the mole that was supposed to drill in. Every time it drilled in, it popped back out. They've spent the most part of 2009 bashing, smashing, crashing, hitting it, knocking it sideways, but it kept popping out. And they've now given up because they'll just use energy that they can't, they need for other things. It's a shame because it would have been interesting measurements. Most recently, and these are images that came down last week, they're using the simpler arm to bash, to cover and bash. And you can see here, there's the wok. And they're trying to put more, it's like being a 5-year-old in a sandbox. They put more of the surface sample onto that feed to try it because they've got lots of noise in the signal. Now, they're not quite sure why. everything that they had not expected has happened, and everything they wanted to have happen hasn't. But that's exploring Mars for you. Here's why InSight is important. Tying in will give you exact numbers for how big the core is, how big the mantle is, and then the crust. And last week at the LPSC meeting, there were 3 papers that all came up with slightly different numbers. The problem is it all depends on the assumptions that you put into the models. And at the moment, there isn't really enough data to say, well, this one is more accurate than that one. So over the next at least 2 years, they've got funding for 2 years, possibly 3, possibly 4. There will be more measurement, and that will take that vague guess to something more palpable. The problem is, because they've not been able to measure the heat flow, that number is still an unknown. So in many ways, we're back to the 19th century. We're at the 19th century stage for the interior of Mars, as we were in 19th century observations, when people put whole oceans on Mars. One thing that's happened with Mars exploration is that you'd be amazed at how unlucky people have been. So here is the best image of Mars from about 1964. There's Elysium. They didn't know that's just where InSight landed. It was known as a plane. And Mariner 4, the first successful probe to fly past, the aim was to zoom in as much as they could. And as Mariner 4, the model of the space age, that was the building. It's amazing how far we've come from a flyby of that to Perseverance. It had the first sort of digital camera that was sent into space. The famous images there of a very sort of barren surface. But here's the kicker. Mariner 4 missed all the interesting stuff. There's Olympus Mons, the largest volcano in the solar system. There are the other 3 on the bulge. And even today, there may be mysteries that suddenly come out of nowhere. It's fascinating to me, because you'd think we would have Mars all figured out. There's lots of things that will, to be discovered. To me, the greatest space mission ever was Viking. I was 12. It was aimed to answer the question of life on Mars once and for all. It consisted of an orbiter. It dropped this aeroshell in which was a lander, and there it was. It was the height of, it was mission impossible for real. They had lots of fundamental things that they had to solve to get that mission to work. Here's the Viking lander. It's got 3 legs, so it's a tripod, high gain antenna. They had 2 cameras. They got a weather instrument. They put the seismometers on the top because that's the only place they could fit them, and they didn't work very well. But the most important thing was the sample arm. And for $2.6 billion, which is about $5 billion now, it was sent to try and solve the mystery. How far we've come, 1976, the highest resolution images, then about 20 meters to 10 meters with the B camera, as it was called. They were able to then get the images, and in those days, they literally printed them off and stuck them on a wall. And to try and work out what were safe landing sites, Paul Mazursky, famous geologist, Mike Carr, originally from Leeds, a lesser spotted Carl Sagan, they printed off all this stuff, and they got 400 graduate interns to count the number of craters, working on the principle if there were fewer craters, it was probably smoother. The mission project manager Jim Martin, who's a remarkable engineer who wouldn't put up with any nonsense from scientists. On every space mission, there's always this between engineers and scientists. The orbit that the Vikings went into, the only reason I'm showing you this is purely very simple. So it came into an orbit, it was a long looping orbit, and the periapsis, the near point, was to over the landing site that they chose. The reason for showing that is the Chinese Tianwen orbiter has exactly the same orbit. It's a long involved thing with the periapsis over the chosen landing site. The week before the landing, Jim Martin said, I don't want any of you coming back afterwards and saying, I wasn't sure. We are voting on this. Are we okay of landing this landing site, Chrissy Planitia? And that's a photograph of that actual meeting where he made sure that everybody said yes. And it worked. And there's the famous image of the surface of Mars. There's the landing footpad. And you can see there, because it was a very, very slow sort of scanning camera, more like a fax machine than a camera, because dust was still in the atmosphere when it kicked up when it landed. And again, an iconic image of the space age. Here's a rarity, a happy, smiling Jim Martin, because they thought one would work and the other would crash, and both worked. So they were very, very lucky. And I think, they did deserve the champagne. But they were incredibly lucky, and luck plays such a part in exploring Mars. If the lander had come down, just 30 feet away, it would have landed on this rock. It would have been knocked to smithereens because they had no idea what the surface was like at that resolution. What you can see there is a hint of clouds, and you can see there the weather instrument. To me, when I was 12, the greatest thing I ever heard at that point was the first weather forecast from another world. And there's the actual forecast written by hand, stuck on a wall in the press room. Light winds from the east in the late afternoon, changing to light winds from the southeast after midnight. Maximum wind was 15 miles an hour. So that was 1976. Seymour Hess, a pioneer of Martian meteorology. This came down last week. This is from Gale Crater, where Curiosity's landed. It's now autumn in the northern hemisphere. Minus 13 to minus 74. The atmospheric pressure, we're talking about 6 millibars. So it's the same atmosphere as 100,000 feet here. The UV ultraviolet is moderate or high. Mars hasn't changed that much. The weather is very, very similar. It's a freezing, desiccated world. When the Vikings landed, and you can see the shadow of the meteorology boom there, everybody was waiting for the first sample to be taken, and there's the actual first trench. It swung through, it dropped the stuff into this hopper, and then here's the Mission Impossible bit. Into a thing about the size of a gallon, they built a completely self-contained biological laboratory. It should have cost something like 20 million. It ended up costing 60. It had 3 experiments, one of which basically assumed that two of which assumed that Martian life would be similar to terrestrial microbes that adopt to Martian conditions, the label release, and the gas exchange, and the paralytic release, which I'll come to. Here was the fun and excitement in July 1976. The labeled release worked by getting a sample, humidifying it, and feeding it what they call chicken soup. It wasn't chicken soup, it was a kind of radioactive broth of lactose. And if there was anything alive in the soils, it would give off this. And the first run, as it was printed off, we spoke to people who were there by the printer, and one of them said, "Oh my God, it's positive." And the first run, it looked as though there was something alive on the surface of Mars. There's Gil Levin, who built that instrument. There he is the next day. You don't need to say, I don't need to say he thinks he's discovered life. You can tell that by his face. His instrument effectively tested positive, but none of the other ones did. And the next day, Pasadena, August the 1st, they very, very said, well, we're not quite sure, and hummed and hawed over that. And that's where biologists have really been for the last 40 years in this wilderness. Here's the problem they had. At those days, they didn't understand the chemistry of Mars, the surface, how it was all fitting together. And there was the actual blackboard where it was, scribbled out what's going on now. The physicists amongst you can see there's a quantum of something and all the energy and all the chemistry, trying to understand it. Now, for the rest of us, think of Alice in Wonderland. Alice goes and sees the game of chess, and she's trying to understand how the game of chess without knowing the rules. And that's exactly the same problem that the biologists on Viking had. Norm Horowitz, Caltech, who built the paralytic release, he said his instrument showed nothing, and he said his instrument was more unequivocal than anybody else's. The Viking biology team wasn't a happy ship, and 6 months later, life on Mars neither proved nor disproved by Vikings. That's where we've been for 40 years. Gil Levin is a holdout. When I was on the Times 25 years ago, his instrument basically tested positive on Mars. He is convinced that life was found. He is a voice in the wilderness. There's a kicker to this story that's really quite interesting. If the White House is briefed in a science fiction film, it's something significant. And it's really opening a new vista into trying to understand Mars. Excuse me. The Phoenix lander came down in 2008. It landed in what was known as Green Valley, which is very strange because it's not green and it's not a valley. And it's the most far north that there's ever been. Again, that was just a repeat of the slide before, 67 degrees north. It's known for many years there's ice and water probably under the surface, has frozen, and within a few days underneath the Phoenix lander, ice formed. Even more significant, they dug a trench, and there, for the first time, anybody had seen ice under the surface of Mars. The big question is how much and for how long, but we'll come back to that. There's obviously water on Mars. Here's a crater that even a 5-year-old would look at that and say splat. So in the past, there was enough water around to cause splats when things hit the surface. But you need to look at the soil to find out. So here is the Phoenix mass spectrometer. It was basically the grandson of the one on Viking. There's the one on Viking, Mission Impossible style. It was built by a remarkable guy called Klaus Beimann at MIT. There he is. He sort of looks like Elvis in that photo. He was better known for being a sort of dapper chap. He really pioneered the technique of taking a gas chromatograph mass spectrometer to another planet. The gas chromatograph bit means you heat it up and look at the spread of colors. The mass spectrometer is you use electromagnetic field to sort out what you're seeing. Very, very difficult instrument to make, virtually impossible to send into space with 70s technology, but it worked. And here was really the death knell for the idea of biology on Mars in 1977. His instrument, a gas chromatograph mass spectrometer, in none of these experiments could organic material of Martian origin be detected at detection limits. In other words, if there was life, where were the bodies? If there's going to be life on Mars as microbes, you'd expect them to be those long chains or to involve long chains of carbon, organic chemistry, nothing. So that really was, several people said, no organics, game over. So back to Phoenix, 2008. This sample that the arm would come in, drop it, it's very messy there again. And they discovered something curious, which again hasn't made any headlines, but is quite significant. So another instrument on board the Mars Odyssey has been measuring chlorine on the surface. Again, it's there in very, very small amounts. We're not talking about swimming attendants on Mars. We're talking about chlorine that's come from space, probably brought by meteorites. And there's chlorine there. Now, in the Viking measurements, they discovered things called chloromethane and chlorobenzene. They thought at the time, this probably is something to do with the solvents used to clean the instrument. But because chlorine is now known and because the Phoenix lander discovered these, so this is the most technical chemistry I'm going to give you. So there is a benzene ring with a chlorine attached. That's what Phoenix discovered. What that means is there's the molecule. So you've got carbon and hydrogen, and off the end of it, you've got chlorine. But look, there's carbon. Where did it come from? Very simple terms, it's a chemical genie. So I'll just go back very quickly. They discovered chloromethane and chlorobenzene. Curiosity's found it since on some of the ancient soils where it landed. So it's obvious that there's some sort of carbon that's there on Mars. And what they've realized with the Viking measurements, that they heated it up to about 1200 degrees. And what that meant, and there's one very, very strange property of chlorobenzene. It sets on fire at a lower temperature. So in other words, somewhere in all the Viking data that's there on microfiche and spools, and there's a team at MIT that have been putting that together, they think that somewhere in the Viking measurements, there might have been carbon, there might have been organic carbon, but it actually set on fire because of the presence of chloromethane. And what that means is that a researcher in Paris, Melissa Guzman, is looking through the chemical entrails of this to see, actually, is there a clue from the Viking data that there's something that we accidentally missed because they weren't aware of it. But really, in recent years, here is the other main thing. 2018, which was the starting point for me to get back interested in Mars again, was organic matter has been found in mudstones. That really is a significant discovery that brings life, the pendulum slightly towards life again. One thing I need to talk about very, very quickly about Mars is the Chinese Tianwen mission. China is sending its missions all over the solar system. The orbiter's there, it's got a radar that will be looking, it's got the same kind of suite of instruments that American and European orbiters have. They've released one image, it went into orbit the day after Hope. There's the North Pole of Mars, so it's looking down on the polar ice cap. They've released the potential landing site, which is in Utopia, which is interesting because that's where Viking 2 landed. It's arrived, it's in this orbit here, the sort of red one, And over the next few weeks, it's going to change with its periapsis so that it will be brought directly over the potential landing site. It's basically had to come in on an equatorial orbit, fire, and then sort of flipped over into a near polar orbit. A very tricky maneuver to make, but they seem to have done it. There is the orbiter. It's got the same kind of instruments that Maven's got and some of the other missions. Sometime in April or May, that's as precise as they've been, it will dispatch its version of a landing mission. They don't know exactly when, but there's a small video that they've released. Again, a quick reminder of all the landing sites, including ones that have crashed. But there's Viking 2 in Utopia. It was much colder than where Viking 1 landed. The region of Utopia Planitia is massive, by the way. It's about the same size as continental Europe. It's not just a small region. And they've said the chosen site is going to be somewhere on there. And they've released this. That didn't really tell you much, but they're hoping for what they call region number 5, which has got the lowest probability of dust storms. So that will be sometime in April, May that it will come down. On board the orbiter, they've got a camera that's like the HiRISE instrument aboard Mars Reconnaissance Orbiter. So it's taking images with a pixel size of 5 centimeters. What that means in plain English, that's better than Google Earth. So if you want Google Mars, that's the sort of resolution now possible. There's the landing site again. They've not provided any scale. They've not said where they're going to land, but you can see there's ice already there and ripple effects inside the craters. It's a very, very colder landing site. There's the lander. It's got a ramp that goes in one direction only. It will land. It's about the same size as Spirit and Opportunity, which is smaller than Perseverance. It's got a series of instruments. The question is, how quickly will they release the data? They will into the scientific community. Will they show the landing live? Nobody really knows. But it's a reasonable suite of instruments, similar to Perseverance and also to the European ExoMars. Like the good old Soviet space program, they tease out details. Here's one. There's the lander. It's about that big, and they were testing the subsurface radar by pushing it along in the Gobi Desert. For those of you who like sizes and data, that's 240 kilograms. I say the Perseverance is about a ton. So it's smaller, it's got the same kind of instruments, and April, May, we'll find out if it's successful. But this is how far we've come. There's Pathfinder we were talking about before. It's the size of a microwave with 6 wheels on it. That worked. So they built Spirit and Opportunity. That's the size of the Chinese rover and also the Rosalind Franklin. And now we're with those good old Perseverance, the engineering model. That's how far we've come in 25 years, let alone 50 years. The big question today about Mars is the one that's always been there, and it's really how much water was there in the past. So there are the atmospheric models that people are trying to get the numbers to say this is how much water there could have been. The problem is the atmospheric models don't tie up with what the geologists are seeing. In other words, the features that should be there, the models predict from the atmospheric analysis, they're not there. There's no rainfall, there's all sorts of different things. It used to be sort of separated quite a great deal. They're coming together slowly. But the question of water and following the water, because the history of water, there was probably enough to be a vast amount, certainly in the Northern Hemisphere. The question of where did the water go is tied into the evolution. It's still not known. There are still many big unknowns about it. Just last week, there was a paper, you might have seen it on online news, that a lot of the water could have gone into the crust because rover missions have been discovering how much water can now be found in these different regions. So really, even before looking for life, it's follow the water. Where has water been on Mars? Now, some people like to say there might have been an ocean. The best description I can give of that, because if there was a vast amount of water, it could have flooded the Northern Hemisphere if the atmosphere was thicker. We spoke to somebody for the book who said, some days I think it's really good, other days I think it's very silly. And that probably is the best analysis of where we are now, because in 2023, if the ExoMars rover lands on the edge of Oxyoplanum, that is the edge of one of these regions here where there might have been the shore of the ancient ocean. But it's an interesting theory, but it's like some people like it, other people don't. But the interesting thing about water is what's been happened with the Curiosity mission. Here it landed in another crater, Gale crater, came in here. What that shows is the landing site. Something happened to gouge the crater out. The center of the crater sort of kicked up in the middle, and then geology, the geology's happened ever since. But in recent years, and this is a fantastic view from a couple of years ago, that shows what they call mudstones. And what that means is there had to be, the only way you can make those kind of features is because of water. How much water, what its temperature was, people are still arguing. But it's showing that there was enough water there to bubble under to cause clays, to cause mudstones. This was just as we finished writing the book, an image, vast amounts of data. It's showing where Curiosity is now. It's actually gone up there and turned right ever so. You can see the images of a couple of the hills that it's seen. But what's significant about that is this region here up to there is made of clay. So it's mudstones and it's water that's been bubbling under there that's been hot enough to cause clay. And then after that, it's now into the sulfate region. Again, because geologists speak with forked tongue, what that actually means is the atmosphere significantly changed, probably 3.8 billion years ago. That there was then more sulfur in the atmosphere. This is how sulfates were laid down. That would have probably come from the volcanoes. But before then, there would have been clays and water, and there was a threshold that life cannot cross. So any time beyond 3.8 billion years ago, and here was something that was discovered again in 2019. They christened it Old Soka purely because it looks like what it says on the tin. It's a rock that was being caused by water evaporating and leaving the kind of shapes and the minerals, because they've dug holes into it and taken bulk samples. And that really is telling you that conditions would have been okay for life to have formed. And it could well be that Mars was very similar in those ancient times to Altiplano in South America. There you've got water on the surface, you've got volcanoes. What's interesting with Altiplano is the water evaporates. There's no sea for it to go into. So if the atmosphere was thicker and conditions were more clement, that's what you might have had on Mars. Here's one I made earlier. I took that in Iceland. If you add to that the possibility of hydrothermal vents, then you've got all the ingredients for life. So I'll go back to it. You've got a core that was more active, so it would have stopped some of the stuff coming off the sun. It would have been more active. You've got water on the surface that was just the right pH. It wasn't too acidic. You've also got a possible heat source from underneath because there was more volcanism. And that is why they've landed in Jezero, because all the elements that you want to see if there was ancient life, they are somewhere, they might have been present there in Jezero. I told you earlier, that little green dot is where Perseverance has landed. It was within a mile of where they're aiming for. And look at that feature there. They called it Kodiak, and it just looks like a knobbly thing. But actually, there's the image. You might have seen that. And a lot of the geologists seem to be quite excited because it's similar, or it could be similar. You've got the edge of the crater behind it, but you've got this feature here. A geologist I know who goes to Antarctica quite a lot said it could be very similar to this sort of thing in McMurdo Island, which is where there's, you can see that there was a feature there and there was greater erosion in the past. So Mars and Antarctica, it's in the book, we start the book in Antarctica. There's lots of parallels. Here is one of the latest images. The rover is going to go off in that direction. You can see there its track marks. Very, very quickly to go through the instruments. So no chemical oven. There's different instruments. The main interesting thing, the SuperCam, it will zoom in. It's got 23 cameras dotted around, one of which is on the end of the sampler arm. It's got a weather station, and for the first time, it's working. They said this last week, so we might finally get really detailed weather data and certainly wind measurements from the surface, and InSight has been doing that as well. This came down last week from an engineering camera underneath. It's looking at the arm there with the instruments on the end, and it's this that will be the excitement in the next few months. One of the instruments on the end of it is called Sherlock. It's a long involved acronym, basically a Raman spectrometer with a tunable laser. And what it's looking for are those chemical rings again, because what it will do, it will fire a laser in the ultraviolet and look for the signal that comes back. And each signal it gets back is absolutely characteristic of what's there on the surface, but it's got to get really up close and personal, and that's what it's going to do. All scientists like to use the word paradigm, but there it is, Sherlock. And really the reason they give it an acronym like that is very, very simply because the way it's going to look for stuff is exactly like the other Sherlock Holmes, and there's Conan Doyle. How often have I said to you that when you've eliminated the impossible, whatever remains, however improbable, must be the truth? And that is how the Sherlock instrument and the other ones on the end of that arm will come to find information. Again, that was last week. It came down. It's now gone through its engineering tests. They've taken spectra of the shutters in front of the instrument, and they've actually detected the paint that it was painted on. So they're all working absolutely fine. Here's how it does it. It will zoom up towards a rock. This is the pixel instrument. So you've got Sherlock, which is looking in the ultraviolet, and you've got pixel, which is a shower of X-rays, and it will tell you the elemental composition. It will zoom straight up to there, and it will tell you exactly on a microscopic scale exactly what's inside the rock. It's taken with it this. Now you can see here, this came down over the weekend. This is the test calibration that they will use. And on that side there, you can see stuff that's actually made of spacesuit material, because they want to see over the next few years how a potential spacesuit would survive on the surface. The interesting stuff is here is a sample of a meteorite that came from Mars. So what's happened is a meteorite that crashed into Oman in 1999, known to be Martian because the gases trapped within it matched the measurements made on Mars. And here, there's a bit of it in Houston. There's another bit of it at the Natural History Museum. There's another one at JPL. So when the Sherlock fires its laser, the signal comes back. If they think, hold on, we're not quite sure about this, they've got this in the laboratory to test. And that will give them the ground truth that they've never had before. Again, why has it landed here? Well, the interesting stuff are the carbonates, the landing zone there. The carbonates that could have been, it could have been it could have been a lake that was fed by water coming from elsewhere. They've already said last week that this rock here, whose name is, they've given it a Navajo name, and I don't want to mispronounce it, but that's going to be a possible target that they'll start firing lasers at. So it looks quite interesting. You can see these rocks here that look ever so slightly volcanic. So it is a grab site mix. There's lots of different geologies. Why with carbonates? Well, here you think about it, an atmosphere of carbon dioxide. If there was water, you get seltzer. If you have heat and you entomb carbonates, you get a shoreline like this. Now, nobody is saying Mars could have been exactly like this 4 billion years ago, but what may have formed are these stromatolites, and this was the press conference before the landing. On Earth, the oldest microbes have been discovered in stromatolites in Greenland. So if they can find something similar, that would be great. So they've landed. They're going to then spend the next 2-3 years doing that. But the problem with any space mission is you don't know if in next week there's a problem and the whole thing shuts down, or it will go way beyond. So they're trying to balance now what they want to do to get as much material as they can. Just last week, they dropped part of the instrument belly off so they can start one of the experiments, the MOXIE instrument. They drove off, and there it is. I just thought that was quite funny. Typical American tourist, littering everywhere. And then literally at the weekend, this bit came off, and what you're seeing there, it doesn't look very, in fact, rather than me try and explain it, there's a fantastic animation on the JPL website, but it's this little helicopter on its side. And what it will do is it will drop down onto the surface, the rover will trundle off, and then this little beast will attempt to fly. Will it work? They think it will, but nobody knows until the moment. And anybody who's been involved with Mars exploration will tell you, you never know until the moment you go click whether it will work. But what it means is this could be a new way of looking at Mars. It might be a way of getting into sort of little crevices and parts of Mars that you didn't think you could see. There's a little camera on board there. So what may happen, and there's a press conference this week where they're going to say when they're going to do this, it will be within the next month, is the rover's got cameras, it's got movie cameras, there's one there, so you'll have the full HD experience of flying on Mars. To end very quickly, I started writing about Mars in the illustrious stuff. I edited this book, Race to Mars, that was meant as a pun, not an actual race. One thing I learned is that every space spectacular, like the one in 1988, the Soviet Phobos mission, anything that went wrong, could have gone wrong, went wrong. And I was then in newspapers when I was writing about that. You can never predict what's going to happen. 4 years later, Mars Observer at a cost of 600 million, that was lost. I've been to JPL many times. There is an engineering model of one of the rovers, but I'm, not a reporter anymore. I'm writing other stuff, as you heard. I teamed up with Elizabeth, who is a PhD. She's also been to Mars, as you can see there, and actually been to a Mars analog and spent 2 weeks there. She's probably the greatest reporter on space writing today in terms of covering absolutely everything. And finally, to end, we just should talk a little bit about ExoMars. It's been delayed. There is the Rosalind Franklin rover. The difference is on its landing site, on its lander, there's a ramp forward and back. It doesn't have to do a 3-point turn. It can move forward or it can reverse. Again, about the same size as Spirit and Opportunity, and it was built in Stevenage. The problem ExoMars has had with these parachutes, if you don't do the fancy sky crane, you have a big parachute. And ExoMars, this one will have the biggest parachute ever made. In 2019, they kept failing in tests. They thought originally that was a JPL. JPL helped them with the they looked at the ejection mechanism. They thought something was catching. The most recent thing I've seen is they've still got problems, but they've got 2 years to fix it. Coming back to it and seeing space agencies, one thing that I'm always amazed by is how boring space agencies make something really interesting, as with this graphic. But this is explaining the next few steps. So, VUMF, there's Perseverance, it landed. 2026, the next one, go and land what they call a fetch rover. It will trundle around, bring samples back, and then the third thing it will come do and come back to Earth. That's the technical stuff for those of you who like technical stuff. It's a very, very ambitious schedule. To me, it's more like the villain in the Bond film. The villain in the Bond film says there are 2 ways to disable a crocodile. One is to shoot it, and the other, you put your hand in its mouth and you pull the teeth out. And the reason for showing that is you can't just get a sample of Mars and say, oh, look, there's the Earth, and shoot it in one go. There are lots of very, very difficult steps that if something goes wrong, you don't know if it's going to work. The first thing they've got to do is to decide what are they going to do with the samples that Perseverance takes. One idea was you collect all these caches, as they call them, they're not that long, and you leave them on the rover. But if the rover dies or something happens, they're going to be stuck on the rover and you can't get them off. So there's going to be a balance between leaving these samples, but you don't want to leave them too long in case they're covered by dust and very difficult to find. Here is the schematic of what they're going to do. There's the landing ellipse, it's landed somewhere there. That's the green is where it's going to go, and in 2026 the fetch rover will follow. How far it will get, and they need to try and make sure that the follow-on lands as near as possible to where the rover is. Very, very tough to accomplish. Here is the schematic of that rover. It doesn't do anything apart from, it's a Martian minicab. It trundles around and it picks up the samples. It's got to travel 3 times faster than rovers do at the moment to be able to do that. It's then got to trundle around, pick them up, put them back into the spacecraft. There's an ascent stage there. You take that with you. In the same way that you can't predict the atmosphere going in, coming back when you're in orbit, you just hope that you're in orbit, and it can't be done in real time. It's got to be done automatically. So there've got to be increases in autonomous control. And you hope when you're coming over where you think the ascent stage is coming, that you want it to come from there, but if it comes from left field, again, the James Bond thing, sticking your finger in and taking the teeth out individually. Just recently, an engineering review of the mission has said, yeah, it's okay. We think it's complicated, but there's nothing fundamentally wrong. So that will be the big spectacular. Because one of the things is, why go to the trouble of spending all this stuff and taking all the hardware to Mars when you can try and bring it back and look at it in your own laboratory? And that's really where we are. So that's going to be the next generation, the next excitement. That's as much as I know. And again, one final plug for the book. thank you for listening.
Thank you.
Thank you. That was really interesting.
Excellent.
Yep.
Excellent.
Excellent talk. Yep.
Where's the gallery? Wait to gallery view. Wait to gallery view.
Nicholas, could you shut your screen share, please?
Yeah, I'm going to stop sharing. There we go.
Thank you.
Oh, what's that?
Any questions?
Hey, not so much a question, but that was absolutely terrific. Absolutely loved that.
I don't use complicated. Sorry, I'm not a scientist, so I don't overcomplicate things.
Something I was hoping you might know about 3 or 4 weeks ago, one of the ideas of testing the seismometer on the InSight lander was that when the body of the ship from Perseverance hit the planet, then they would know, well, they know what speed it was going to hit, they knew how heavy it was. So there should be a signal that would be extremely detectable. And they could then use that to calibrate the seismometer.
I think what would be more likely is the thing that they're hoping for a holy grail is, and this has already happened, but InSight wasn't there, the Mars Reconnaissance Orbiter with the high rise. There's a bit of feedback somewhere.
Yeah, somebody, if you're not talking again, could you just mute yourself, please? And then unmute when you're talking. Okay.
Yeah, sorry. The Mars Reconnaissance Orbiter has the high-rise camera that can see each pixel is 5 centimeters. It's discovered craters that weren't there 2 years before. The trick would be to find the crater that suddenly appeared and to calibrate it with, so you can see how big the crater is, so you can, half equals half mv squared, how much energy hit the surface, and if you can detect it. The problem is, Mars has been much windier, and there's been the problems with signal noise from so trying to find and isolate that particular thing. I saw that paper, somebody said that. I talked to a couple of people, they said if we can find it and it's there and it's obvious, we'll find it, but I've not heard anything, and it really is a very, very tough mission. And the other thing that you can't do is what the Apollo astronauts did when they crashed part of the lunar module into the surface, and the moon famously rang like a bell, one of the seismologists said, because of the fact that you don't want to put any earthly microbes into the surface of Mars. So it would be nice, they want something that they can calibrate, but whether they'll find it, it's a very, very tough measurement to make.
I spent some time looking for that, if there've been any results through yesterday. Couldn't find
Yeah, I don't think so. It's because they've had this problem with the signal noise, and they've also got this thing with Mars is so much more windy than they thought, and it's causing havoc with the measurements. This is why, by the way, they said last year there were 450 possible Mars quakes, and in the year it's only gone up to about 500, another 50, because they're having real difficulty trying to figure out what they thought they saw.
Thanks.
Any other questions?
No, I'm very good at asking.
No.
There you go.
No. Have you any?
I can see John Davis has got 2 in my book, one of which he reviewed, I remember. And he had the grace to write to me to say that actually I was right and he was wrong. He probably doesn't remember that, but I'm the sort of person, it's like the day of the jackal. If I get a bad review.
Before you joined, I did say I did remember your name from somewhere, and I was trying to place it.
It's all right. Even I don't. I keep appearing in documentaries, and I'm the only person I've never heard of. So, but don't I was only joking. It's ancient history.
Right.
Yeah.
So
Yeah, we thoroughly enjoyed it. It was very interesting.
Thank you. I mean, as I say, I've tried to. I hope what I find interesting is because astronomers like looking at things, and there's different things of different people. I am coming at this from the point of view of being an old newspaper hack. But as I say, I kept everything on Final Post, and everything is in there. And we've had some great reviews. And it really would. That's it now for me with space. In fact, this is the last Mars talk I'm giving, because we finished
Is
the
it?
project.
Oh,
I know. Yes. Boo, all that sort of stuff.
that's a shame.
To stay relevant, you need to follow it. And to be perfectly honest, I'm off doing other things. And I said to people, I'm going to end on a high note. So this has been it. But thank you for
Well,
listening.
well,
And it brings
thank
back happy
you.
memories.
Yes.
Happy memories of the A74 turning left
Yeah.
at Cross of John.
Thank you for speaking.
Yeah,
Really
that's very good. I mean, I like the. I guess out of my your same sort of age as you, but a bit older maybe, because I remember them Viking landing. In fact, I remember Mariner 6 and 7 fly past because they were just.
I mean, people. What's interesting to me is people forget the early years, because I mean there has literally been a tsunami of data since. But what I do think is interesting, if as Melissa Guzman in Paris is looking through the Viking data, and she's online, by the way, she's Viking GCMS, and she wants citizen scientists. So if you've got some spare computer time, you can help her. Will it resolve this? Who knows? But what I think is, with the question of life on Mars, it's like a pendulum that swings and goes. And it was heading towards there being the possibility, and Viking landed. And it was the worst possible thing, because nobody could say there is life and nobody could say there isn't life. And it's really that kind of, and now it's because of the situation with the water, people have said, okay. Now, will Perseverance find what it's looking for with these biosignatures? You're talking about very, very fancy chemistry, and at some level, where chemistry becomes very fancy, it becomes biochemistry. The interesting thing to me is the people who are doing the research on the teams, they're all spectroscopists. You won't have seen their names on many papers to do with Mars research today, because it's a very, very specialized form. But within that, they might find something. Wouldn't it be great if they found a lipid? Or wouldn't it be great if they found a DNA, and again, the only way you would ever know it was completely Martian is if the chirality, which is the strange property of right-handedness and left-handedness, and if the chromosomes or whatever are in a slightly different order, which is the plot of one of the sci-fi films. So before anybody stands up and says we've discovered life on Mars, there's quite a few things that they've got to go through. And I tell you, because again, in the book, because we're journalists, we spoke to the head of news at JPL, because we think if there is a discovery, nobody can keep quiet for long enough anymore, and it will appear on social media. So keep watching social media. The most ridiculous, as some of you know, was last year or 5 years ago, the LIGO, the gravitational waves. One of the scientists' PAs or somebody tweeted a picture of a cake that she'd baked 5 hours before the discovery that said, "Congratulations, woohoo, gravitational waves." So everybody knew they'd discovered it because somebody had posted a photograph on social media. And I think that's what will happen with this. I think it won't be, Elizabeth working for space.com or me appearing on something. There'll be something on social media that somebody will see and then put 2 and 2 together. Hopefully not to add to 5, but to get the result. And again, to finish, I think unequivocally, when the samples are brought back to Earth, and they're talking about 500 grams, which is about, you cook that for your tea, mince or corn or whatever, and those sort of little samples will be given out, sort of very, very grudgingly, because they will be rarer than hen's teeth, but something within them will be found. Whether it will be a biomarker or something, but again, it's looking good if all the cards line up. But and John and I probably won't be here. There'll be youngsters who will see that, but it's really exciting.
Mm-hmm. Yeah. Mm-hmm. Yeah. 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 Totally.
Right, I'll stop talking. Thank you.
Right.
Yeah,
So.
great.
Yeah.